Hey guys, this is Ben Morrow. I'm a senior concept designer and art director in the game and film industry, currently working on Halo Infinite. Today I want to talk to you about the benefits of using GPU rendering in your workflows. I've been using this the past year and it's improved my render speeds hugely and saved me a ton of time, and I just kind of wanted to do some tests and see some real world results with all this stuff. A lot of the videos I've seen online have been using like benchmarks or like different types of scenes and things that weren't really applicable to the work I do as a concept artist. So I wanted to take a couple scenes that I made, this one being one of the ones I did in the first video, and then a second scene I made new for this, which is kind of like an ancient temple ruin type scene. Both of them using some cool assets from Kitbash 3D, the first one being from their industrial set and the second being from their ancient set. I wanted to focus on two different types of scenes today, a dark foggy scene and a bright sunny scene, which is a couple different types of scenarios that I would usually run into on different jobs. The dark foggy scenes in particular can be some issues with noise and grain and stuff, and I wanted to go over how to tackle some of that and some new cool things coming down the pipeline in Blender 2.81 that can help improve that and speed things up for nice finished renders. So my current work machine has 4 RTX 2080 Ti's, thanks to nVidia for providing some of these for these tests, and a 32-core Threadripper. I've been experimenting a lot between the pros and cons of CPU rendering and GPU rendering, and I wanted to go through a bunch of different tests to see the render speed of just the CPU, the render speed of one 2080 Ti, 2, 3, 4, etc., and just see the speed increase with each of those and how they handle these different scenes on their own. I just thought that would be kind of an interesting experiment and something I never really kind of tried out myself. I just kind of went full on everything at once. One of the cool things about Blender is that I can just use anything you have, so it can utilize all 4 GPUs and my CPU at the same time, so my render speeds are just super fast. So I never really took the time to go through and try out each one individually, so I thought this would be a really interesting experiment. So the render settings I'm using today are 5,000 pixels wide. This is typically what I would use for a final rendering for client work. The samples I'm using on this dark scene in particular is 200 samples. This can get a little noisy with cycles, but I wanted to show some cool stuff you can do in Blender 2.81 with denoising that can smooth all this out, and also some really cool stuff that was added for the nVidia RTX cards that increases the render times even faster than they already are. So just a lot of cool stuff that's getting updated in Blender that will just take these fast render times and make them even faster. So first I wanted to show the scene in Eevee. I think Eevee only really uses one GPU. I've done tests on laptops and they only had one GPU, and the render speeds are usually around a couple seconds. So this 5K image with 12080 Ti was around 8 seconds, and to me this is really good. Dark scenes like this with fog and stuff, I feel like Eevee in particular does an amazing job. There's no grain or anything. It just renders really clean and really fast. The shadows being cast by the lights, though, aren't 100% accurate, but sometimes that is not a bad thing. So this was the first test I did. I just wanted to see what the CPU could do on its own, and just my 32-core Threadripper took 13 minutes and 9 seconds. So next I wanted to try just one 2080 Ti without the CPU, and this took 12 minutes and 9 seconds. So one 2080 Ti is faster than the 32-core Threadripper, which was just interesting to see. So the next test was two 2080 Ti. This cut the render time down from 12 minutes to 5 minutes and 36 seconds, which is pretty awesome. The next image is three 2080 Ti for the same scene, and this cut the render time down from 5 minutes to 3 minutes and 42 seconds. Again, each GPU just cutting down render time more and more. The next scene, 2080 Ti, and this cut the render time down another minute or so to 2 minutes and 41 seconds. And the next test I wanted to do was just what I normally do, is let Blender use all my 2080 Ti's and the 32-core Threadripper, which brought the render time down to 2 minutes and 26 seconds. What I found interesting, though, was with the CPU and the 2080 Ti's working together, it didn't cut the render time down that much, but every second counts. So I save an extra 20 seconds using all my GPUs and the 32-core Threadripper. So the final test I wanted to do for the scene was using Blender 2.81 with the new denoiser tools and the nVidia optics upgrades that help speed up the render times. So this allowed my scene to just be really clean without any noise. I think it did a great job, and it cut my render time down to just over 2 minutes. Again, you can see the significant noise level with 200 samples on is pretty apparent, but sometimes that can be kind of nice for renderings. But if you want to go really clean and smooth like you would get out of Eevee, or just want the lighting and stuff to be really clean, you can turn on the denoiser and it does an excellent job. And also shaved off another 20 seconds with the optics upgrades and everything. And this is only using the GPUs. It's not using the CPU at all. So it's pretty cool to see that just my 2080 Ti's, you get really clean, nice renders with low samples. 2 minutes for a 5K image is really great for accurate cast shadows and reflections and stuff in a foggy night scene like this. It's just a really good bang for the buck with all these upgrades that are coming out. So I wanted to show you guys how to apply the new denoiser tools in Blender 2.81. The first thing to do is to render out your image. It'll apply the denoiser on top if you've already set it up, but I'll just show you where to do all that within 2.81. Go to your compositing tab, and normally when you pop this up, it'll just be your render node and your composite node, and you just add the new denoise node by pressing Shift A and going to your filter and denoise, and it will just add a denoise node to your scene and just plug in all the proper channels, and it should be good to go. So if you want to see what the denoiser is doing, you just plug the raw image back into your viewer, and you can just see all the noisy, grainy stuff that happens with the low samples. But if you plug in the noise node, you can just see what it's doing. Just really accurately cleaning all that up and smoothing things out. This just allows us to render a nice clean image really fast with low samples. So the previous scene, I showed some difference between Eevee and cycles, and you might wonder, why would I use cycles, which takes longer, if the results out of Eevee look pretty good already? I just wanted to show a little preview of the next scene, which is more of like an Egyptian desert scene in broad daylight. And this is the Eevee render out of that scene. And you can see the lighting is just kind of pretty general, and, it's not bad, but it's not accurately casting shadows from the light source. And this is the cycles rendering out of it. And you can just see it's really doing a nice job casting all the shadows accurately. You're getting a lot of color mixing in the shadows and light bouncing around and much better ambient occlusion and everything. You get a much better sense of realism and depth in the space. Same thing here. It's okay. You generally get the lights and darks of the scene. It's really fast, but doesn't hold a candle to the level of fidelity you get out of cycles. So you can see all the lights are being accurately cast. You're getting a lot of color mixing and everything. You can also just see generally everything kind of has the same fidelity of the shadows. There's the same blurriness to all the shadows. But in cycle, you just get a much more realistic representation of light and shadow in your scene, which is much better for final renders for clients and everything. Something to keep in mind when you're working, like Eevee is great for darker, foggy scenes, but for sunlight and daylight, it's probably good to use to start mocking up the scenes. But for final renderings, I would definitely use cycles. Same thing here. It renders all the shadows the same crispness, but because this guy is closer to the floor and this giant building behind is further away, it's going to have softer shadows versus this guy that's really close. That'll be casting a much sharper shadow. It's just something to be aware of when you're working on stuff. Maybe you want this kind of crisp, clean look, and you can edit some of the settings to get something a little closer to what cycles might do, but just the level of realism in cycles is definitely worth the time to use for final renderings. So here's the second scene I wanted to try, which is more of a daylight scene. And I feel like this is going to show you a lot more of the benefits of using cycles for final renderings. Again, 5K image. I wanted to try just the CPU on its own in cycles in Blender 2.8. This got me a 3 minutes and 59 second rendering. Then next is the single 2080 Ti, which got me a 4 minutes and 7 seconds, just slightly slower than the 32 core Threadripper for this. And then 220 Ti, chop that down really huge, under 2 minutes. 320 Ti brought that down to 1 minute and 18 for this. And 4 brought it down to just over 1 minute, which is pretty awesome. Next is all 420 Ti, and the 32-core Threadripper brought it down to 1 minute and 6 seconds, just 2 seconds faster than only using the GPU. For the last test, I wanted to try the RTX improved cycles in Blender 2.81. This is only with the 420 Ti, and it brought the render time down to 49 seconds, which is pretty awesome. You know, to have a 5K image for a final rendering in 49 seconds is pretty great. This sort of stuff just saves so much time, and you can get so much more work done every day at much higher fidelity. But hopefully you can see the pros and cons of using cycles in Eevee for different scenarios, and just the speed benefits you get from only a CPU, singular GPU to multiple GPUs, or using them all together. This was a really fun experiment to test things out and get some exact real world numbers for all this stuff. Hopefully this is informative and helps you guys plan your next PC build or whatever you're going to use to help improve your workflows. Thanks for watching, guys, and I'll see you next time.